full day in the OPD, only to realize you still have hours of soap notes, parent instructions, and research tasks waiting for you. This image shows the chaos flooding social media. Dozens of ads promising AI mastery for 99 rupees. But copying random prompts from cheap tutorials is just AI tourism. It doesn't solve the complex friction points of actual clinical practice. That is why the Indian College of Pediatrics designed a dedicated, structured academic program. It is built strictly by pediatricians for pediatricians to address real clinical realities. Integrating AI effectively requires a complete restructuring of your daily practice habits and the re-engineering of clinical workflows. The heaviest burden in any pediatric clinic is the sheer volume of repetitive documentation. This schematic illustrates the solution. An audio waveform of your clinical dictation funnels into an AI processing node, which then accurately splits the data into a fully structured SOAP node and a distinct, easy-to-read patient follow-up document. The same architecture expands further. The central processing node connects directly to patient communication channels, automatically triggering vaccination reminders and routine FAQ responses via chat. Delegating these specific administrative tasks allows you to reclaim hundreds of hours every year, time that goes directly back into direct patient care and clinical observation. Beyond the clinic, you also face the constant pressure of academic output, creating teaching modules, CME presentations, and resident materials. This conceptual hierarchy chart demonstrates how AI accelerates that process. A single clinical topic node rapidly generates multiple formatted child notes, CME slides, an MCQ module, and a visual infographic, all in minutes. When applied to research, the system functions as a funnel. Your raw clinical observations are funneled through a PICO formatting filter, which then helps draft a structured academic manuscript. By removing the structural and formatting friction of academia, your clinical insights move from observation to publication with far less resistance. Applying these tools safely requires overcoming the trust barrier. AI can hallucinate, and in medicine, a hallucination is a clinical error. This diagram outlines the strict legal boundaries of the DPDP Act. Identifiable patient data, in red, is blocked by the compliance firewall, ensuring only safely strict anonymized data, in green, reaches a public cloud model. Think back to your last 5 patient encounters. Mentally separate the moments that required your clinical empathy and medical judgment from the tasks that were strictly data entry. Learning to navigate those boundaries and implement strict ethical guardrails takes time. It demands a structured 6-month mentored academic journey, not a brief webinar. Implementing clinical AI without a clear ethical framework carries immense risk, making continuous mentorship the safest path forward. The result of this sustained effort is a highly efficient practice. Telemedicine dashboards, smart scheduling, and accelerated research processes run smoothly, returning your personal time. This structural chart maps the 7 core challenges the ICP framework solves. It builds up sequentially from trust, OPD burden, academics, clinic automation, research, and ethics, all acting as pillars to support a future-ready practice. AI will never replace a compassionate pediatrician, but doctors who master these systems will practice, teach, and lead far more effectively. Look at how the balance shifts. The downward pull of administrative burnout is easily outweighed by the compounding return on investment from AI integration. This 6-month program serves as a foundational career investment, providing the structured mentorship required to navigate and lead the next decade of healthcare.